Thanks for the nice introduction, Aruna. So this is really new topic for me as well. I'm actually excited to take a lot of interesting questions after my talk. So this work is actually a co-work done by Shin Hyun, Kenny Chu, my PhD student, and my previous colleague Rajesh Ballan and myself. And Shin actually did all the work, but unfortunately he couldn't make it to the conference due to the visa issues, so I'm here to present. So let me get started. Mobile advertisement, as we all know, it has been a very successful profit model. So 94% of the Android applications and 88% of the iOS applications are provided for free, and then they actually make partial or full profit by showing different types of advertisement. So the mobile users actually kind of take this as a reasonable approach because they can try out different applications for free at the beginning. But 70% of the mobile users also at the same time reported disliking mobile advertisement because some of the advertisements are provided as a full screen advertisement. Even nowadays, some advertisements are the video-based advertisement, so they are annoying, intrusive, and disrupt user experiences. So we kind of started to thinking about if there is a way that we can provide the ad-free experience to the mobile users while providing the mobile developers with appropriate amount of the profit. So to this end, our idea is that can crypto mining on mobile be a practical ad-free monetization approach? You probably have some doubt, but let me actually tell you what we find out. So just to give you a very high-level background on what crypto mining means. Crypto mining is a core part of the blockchain system, which you can consider as a distributed database to store the transaction information. So to this Bitcoin system to work, somebody should verify the legitimacy of a transaction, and also somebody should create the digital currencies to provide incentives to the verifiers. So crypto mining actually refers to the computational process to serve these two purposes. And anybody, if you're interested, you can actually participate as miners. And miners get financial incentives like Bitcoins or different types of coins in exchange of offering computational resources. So to see our idea works, we actually asked some of the related research questions. First question, how profitable is the mobile mining? Is it comparable to in-app mobile advertisement? Our second question, do mobile devices have sufficient computational resources for mining, which is known to be computationally intensive? Right? Our third question, how does mining affect user experience? Would users actually allow it? So we quickly implemented our mobile crypto miner prototype. We actually didn't do much. We basically borrowed the CoinHive miner. We actually adopted this miner for two reasons. First of all, CoinHive miner is the browser-based miner with the JavaScript implementations. So we can easily port this to the mobile devices. We actually did one trick to make it work in the background. And the second reason is that it actually adopts the CryptoNight algorithm, which is a memory-intensive algorithm and which adopts the built-in CPU instructions. So this algorithm is not suitable to run in the GPU or modern ASIC processors. So because of this reason, actually, it makes the mobile devices can compete with other more powerful computing devices that can actually run the mining with more powerful resources. So how this works? So basically, developer registers his or her digital wallet to CoinHive miner. When the user runs the app actually requests the CoinHive miner to run for a certain duration. And then this miner actually mines and then get the hashes. And these hashes are sent to the mining pool, and it's actually collated with the hashes mined by other miners. And the proper rewards are given to the miners. So here we actually get the reward in terms of the Monero coin, and this is how our system works overall. Here, one thing to note is that we actually consider this system in perspective of single application. We actually didn't consider multiple applications running at the same time and how to distribute the rewards to different applications. So using this minor prototype, we actually conducted a user study. We recruited 228 Android users aged between 18 to 62, including 85 females. And then we asked them to run our miner at 20% intensity, which is the intensity that doesn't affect, that doesn't heat up the phone that much, and then that doesn't consume the CPU cycles of the phones that much, so that it doesn't affect the running of other applications too much. So we actually split the users into 5 different mining modes and 2 baselines, and then we asked them to run the miner for 24-hour duration. So let me actually explain a little bit about our mining mode. Our default mining mode is the always mode. So it runs the miner all the time unless the device is not connected to the network or the battery level goes below 15%. And the next 2 mode is plugged and plugged fully charged. Both mode actually runs the miner only when the device is connected to the power. The second mode, plugged fully charged, runs the miner also when the device is not only connected, but also fully charged. And the last 2 modes is that, as you can see from the name, unplugged screen off and unplugged screen on. So this runs the miner when the device is not plugged in, one when the screen is off, another when the screen is on. So now it's time to look at our initial result. So let me actually show some of the results about the profitability. So this table here actually shows the duration of how long our miner runs and the corresponding profit depending on the mining modes. Oh well, as you can see from this number, it actually mines very little amount of money. So the number was that like a device earns 0.08 cents to 0.28 cents a day, depending on the mining mode. So this sounds like nothing, right? But what does this number mean in terms of the ad profit? So we actually looked at the Google AdMob profit. It was quite surprising. I didn't know this before. But this map here actually shows something called eCPM, effective cost per 1,000 full screen ad impressions, 1,000, right? So if you look at this map, we can see that close to 40 countries have eCPM of less than 30 cents. So if we do a little bit of back of envelope calculation, we can easily see that tens of advertisements can be covered for many of the countries, and for some countries it could be even more than 100 advertisements. Then you might actually ask this question. Nowadays, the cryptocurrency, actually the price is skyrocketed, so maybe the profit is higher nowadays. What about if those prices actually goes down? So we actually looked at the correlation. To answer this question, we looked at the correlation between the Monero coin price and the mining difficulties. And here, as we can see in this graph, these two are highly correlated. This means that, let's say the price of the XMR actually goes down. In this case, the difficulty of the mining goes down. It means that if we put the same amount of resources, we can get more number of Monero coins. So even if the Monero coins, the price goes down, the eventual profit that we can get for the same amount of the computing resources will remain quite stable. So this actually shows the estimated mining profit per device over a 3-year period when the device is run in mining plug mode. And we can see that the mining profit per device varies, but it varies far less than the changes of the Monero price. So now let me actually show some of the results about the resource consumption. So to earn this amount of money, how does our miner consume, how much of resources does our miner consume? So power consumption, it actually consumes about 3 to 7% of the additional battery per hour, right? This is somewhat noticeable, but I think it can be bearable for many of the mobile users. And another thing to note about the battery consumption is that we kind of noticed that devices were plugged in for more than 3 hours on average, even after they were fully charged. So for at least for this kind of duration, without any battery consumption, miners can run. So now CPU utilization of the mining. So as this table actually shows the CPU utilization for different conditions, I actually want to highlight a few things here. So for many cases, there are free CPU cycles available for mining, because for most of the cases, the CPUs are not that much utilized. And mining consumes about 10 to 13% of the additional CPU cycles. So here, just to sum up, our miner is consuming about 3 to 7% of the battery power per hour, and also the 10 to 13% of additional CPU cycles. But remember, we actually set the mining intensity at the 20% level, and then so that we, depending on the user preference, depending on the countries, we can make the right trade-off to increase profit or decrease the resource consumption. So lastly, research question 3, how does mining affect user experience? So after this user study, we asked the users a few questions, and we asked if they notice any kind of difference, the impact of the mining, in terms of the battery life, in terms of charging speed, in terms of processing speed. And more than 70% of the users did not notice or say even that the mining case was better, interestingly. So this was quite promising. And for those who actually reported negatively about the mining effect, what was interesting was that even for the baseline group who actually ran nothing, 20% of the users actually said that they experienced something worse. So I think this is not coming from the fact that they actually ran the miner and then they experienced something bad. Mainly, in many cases, it actually came from the fact that they actually ran something, and it's from this perception. And we also finally asked if the users would allow mining eventually. A majority of the participants were open to using crypto mining for ad-free experience. And again, similarly, some of the users actually, about 25 to 30% of the users said that they would not allow, but this is not because they experienced something bad about the miners. They just are not open to the new technology, and they didn't like the fact that they're running something in the background. So in this study, we actually showed the initial potential of using crypto mining in terms of profitability, resource consumption, and user experience. And according to our initial research, mobile crypto mining can be an alternative to mobile advertisement, at least for some countries and some users. But then obviously for this, to make this whole system work, we need a lot more study. Thank you.